same denominator, those problems are pretty easy. The problems come for students when you have to have different denominators. And when we have different denominators, we need to make them to have the same denominators. And we do that using our least common denominator. So we need to do a quick review of what it means to be least common denominator. Well, if I were to find the least common denominator of the numbers 10 and 14, I would list my prime numbers of 10, and that's 2 times 5, and the prime numbers of 14 are 2 times 7, and I'm going to keep 2 times 5 times 7. I won't keep this 2 because I've already used the 2 once. So 2 times 5 times 7 gives me 70, and that is my least common denominator. If you need to, you can go back in your book and look in those sections for the least common denominator. So here are examples of different denominators. So if I have 3x minus 1/2, well, I need to find my least common denominator, and in this case, my least common denominator will be the 2, that's my number, and the x will be my variable. So the least common denominator is 2x. So I'm going to take this, I have 3x minus 1/2. So I need to take that 3x and I need to change the denominator to be 2x. And I'm going to take that 1/2 and I need to change my denominator to be 2x. So they both have the same denominator. And to get from x to 2x, I had to multiply a 2 to the denominator. But if I multiply the denominator by 2, I need to multiply the numerator by 2. So 3x is the same as saying 6 over 2x. And here 1/2, I want to turn that denominator to 2x, so I had to multiply by x. But if I multiply the bottom by x, I need to multiply the top by x. So 1 times x gives me x. So 1/2 is the same as saying x over 2x. So then I can rewrite my problem. And where there was a 3x, I rewrite it as 6 over 2x. And where there was a 1/2, I rewrite it as x over 2x. Now I have a common denominator, so I just have to subtract, and that is 6 minus x over 2x. Then I look and see if I can reduce it. In this case, I cannot reduce it. Here's another example. I have 5 over 2x minus 6 plus x over x minus 3. My first step that I'm going to do is factor. So I notice I can factor out a 2 from here. So I have 5 over 2x minus 3 plus x over x minus 3. Then I find my least common denominator. My least common denominator will be 2 times x minus 3. I already have an x minus 3 there. I now need to change this fraction right here to have the same common denominator. So I had x over x minus 3. I want my denominator to become 2 times x minus 3. So I had to multiply that denominator by 2. So then I need to multiply the numerator by 2 also. So this fraction changes to 2x over 2 times x minus 3. So I started with 5 over 2 times x minus 3 plus x over x minus 3. This one can stay the same because I'll keep that same denominator. This one needed to change. So now they have a common denominator. I can just add the numerators, which becomes 5 plus 2x, and the denominator stays the same over 2 times x minus 3. I check to see if I can reduce, and no, I cannot. Here is another example, 1 over x plus 4 plus 8 over x squared minus 16. First thing I'm going to do is factor, so I have 1 over x plus 4 plus 8 over x plus 4 times x minus 4. That's the difference of squares, so it factored. So my least common denominator is x plus 4 times x minus 4. And so I don't need to change this fraction, but I do need to change this fraction. So I'll change that fraction. I had 1 over x plus 4. I want my denominator to become the least common denominator, so I want that to become x plus 4 times x minus 4. So I had x plus 4 here. I need to multiply x minus 4 to the bottom, but then I need to multiply x minus 4 to the numerator as well. So I change that fraction, and I end up getting x minus 4 over x plus 4 times x minus 4. So I went ahead and I changed that fraction. Now I can add my numerators because I have a common denominator. When I add these numerators, I get x minus 4 plus 8. Well, I can go ahead and add those. And x minus 4 plus 8 gives me x plus 4. But then I notice I have an x plus 4 on the top and an x plus 4 on the bottom. So I can cancel those out and I get 1 over x minus 4. Here I have another example. 2 over x squared plus 5x plus 6 plus x over x squared minus 9. First step is to factor. So when I factor this, I get x plus 3 times x plus 2. That's the difference of squares. When I factor that, I get x plus 3 times x minus 3. I look for my least common denominator. So x plus 3 appears twice. I only need to count it once. So I scratched it off one of them. But I need to keep the x plus 2, I keep an x plus 3, and I keep the x minus 3. So this is my least common denominator. So I'm going to take a look at this first fraction here, and I'm going to change that fraction. So I had 2 over x plus 3 times x plus 2. The least common denominator, the part that I'm missing, is the x minus 3. So I need to multiply in an x minus 3 to get that least common denominator for the denominator. But if I multiply the bottom by x minus 3, I need to multiply the top by x minus 3. So I went ahead and multiplied the top by x minus 3. Well, now I can actually use distributive property. So I'll use that distributive property, and I get 2x minus 6. So my new fraction became 2x minus 6 over x plus 3, x plus 2, x minus 3. That was my first fraction. Now let's take a look at the second fraction, and that was x over x plus 3 times x minus 3. And the piece of the least common denominator that I'm missing is the x plus 2. So I need to multiply the denominator by x plus 2 to get the least common denominator, and the numerator by x plus 2. Now, when I go x times x plus 2, I then can go ahead again and use that distributive property, and I get x squared plus 2x. And there's my denominator. Well, now we can go ahead and add those fractions because we have the same denominator. So the first fraction changed to, this is what we had. It changed to this fraction. Our second fraction looked like that. After we changed the common denominator, it looks like this. So now we can add them. So I have 2x minus 6 plus x squared plus 2x. So here we go, 2x minus 6 plus x squared plus 2x, because I have a common denominator. Well, now we can go ahead and combine like terms. And when we can combine like terms, I get x squared plus 4x minus 6 over x plus 3 times x minus 3 times x plus 2. Then I look and I see, can I factor this at all? And it doesn't factor to reduce. I cannot factor that numerator, so I just leave it the way that it is. Here is another example. I have x plus 4 over 2x plus 10 minus 5 over x squared minus 25. So my x plus 4, I can factor out a 2 on the bottom, so I'm going to factor first. I factored out the 2. Here I look, that's the difference of squares, so I factor that to be x plus 5 times x minus 5. I look to see for my least common denominator, I have 2 times x plus 5. Here I had x plus 5x minus 5. I don't need to count that x plus 5 twice, so my least common denominator becomes 2 times x plus 5 times x minus 5. I need to change each of my fractions to have the new least common denominator. So this was 2 times x plus 5. The piece that I was missing was x minus 5, so I need to multiply the bottom times x minus 5 to get my new least common denominator. But if I multiply the denominator, I need to multiply the numerator times x minus 5. So I multiply that out, and I get x squared minus x plus 20 if I FOIL. Here I do the same thing. I was missing a 2, so I multiplied in the 2. 5 times 2 gives me 10. Now I take a look at this, and I can rewrite my fractions to be so I had x squared minus 10x minus 20 minus 10, so I can combine them, and when I combine them I get x squared minus x minus 30. My numerator stays the same. I look to see, can I reduce this? And that actually did factor, and it factored to x plus 5 times x minus 6, so the x plus 5s cancel out. I'm left with x minus 6 over 2 times x minus 5 on the bottom.